Hello all. Hello all. Welcome back. Welcome back to Pure Learning. Cool. Now let's have a small recap. What are all the things which we have covered in our past videos? Okay, let me give you like 5 seconds to think. I really should recollect. If you didn't see the previous videos, just go and have a look at all those things. You'll get a basic idea of all the things which we have been covering till now. And yeah. So the first thing is that we cover the substitution method, elimination method, cross multiplication method, which are the three algebraic methods which are used in solving a particular pair of linear equation in two variables, right? And then we saw graphical method, and then we stepped into the first exercise in the NCERT textbook. We solved one problem in each video, and then we studied about consistent, inconsistent, and dependent pair of linear equations in two variables. So till now, this is what we have covered, right? Now, we have studied the concept of inconsistent, consistent, and dependent variables, but we are yet to solve problems on it. So, in the exercise 3.2, the second problem. So, the second exercise, second problem deals with this particular concept. Okay. So what is this concept about? We just need to find if a given particular pair of linear equation in two variables is a consistent pair or an inconsistent pair or a dependent pair. That's it. So in the third question, the second question, sorry for the slight shake here, my tripod got a bit shaky. In the second question, the first subdivision is that we are given a pair of linear equation, and the equation is 5x minus 4y plus 8 is equal to 0 and 7x plus 6y minus 9 is equal to 0. Okay. How do we find whether this particular pair of linear equation is a consistent or inconsistent or a dependent one? Okay. For that, we need to do one thing. Sorry for the shake, guys. I'll rectify that in my next video. Okay. So the A1. So generally, what we do is, let me write the general formula here. So we have A1. Let me write all these three things here. A1 by A2 is not equal to B1 by B2. This is one criteria. Then A1 by A2 equal to B1 by B2 not equal to C1 by C2. This is one criteria. Then A1 by A2 equal to B1 by B2 is equal to C1 by C2. Okay, we have studied these three criteria. Now what does each of them mean? That's what's important, right? So this means that A1 is the coefficient of x in the first equation, and A2 is the coefficient of x in the second equation. That's it. So that's what A1, A2, B1, B2, C1, C2 stands for. They are the respective coefficients of x, y, and z. I mean x, y, and the constant. C is the constant, right? So when A1 by A2, that is in this case, 5 by 7 is not equal to minus 4 by 6. It is satisfying this case. So what it means is that it has one unique solution. That is, when we draw this pair of linear equation in a graph, we'll get two lines. And these two lines actually intersect at one particular point. So in this one, it means that this is consistent. So when A1 by A2 is not equal to B1 by B2, it means that it's a consistent pair of linear equation, has one unique solution. Has one unique solution. That's what it means. Therefore, what does this one say? This one is a consistent pair. Why? Because I hope that doesn't happen again. It won't happen again. Okay. So A1 is 5 here. A2 is 7 here. Therefore, A1 by A2, and let me just find the B1 and B2. So B1 is minus 4. A1 by A2, B1 by B2. So here A1 is 5, A1 is 7, A2 is 7, and B1 is minus 4, B2 is 6, and both of them are not equal. So which means that this is a consistent pair. That's it. And it has one unique solution. You can use any of the four methods which we discussed. to find that particular intersecting point, to find that particular solution. And when a1 by a2 equal to b1 by b2 and not equal to c1 by c2, this is an inconsistent pair. Inconsistent pair, and it has no solution. And when a1 by a2 equal to b1 by b2 equal to c1 by c2, it has infinitely many solutions, and it's called dependent pair of linear equations. This is what we saw when we studied the concept about this particular, when we studied the formulas for this particular concept. So this is what it means. So by using that formula, we have actually arrived to a point where we found that it's a consistent pair. That's it. So let's go to this second one. You just need to have always have this thing in your mind. It should always, you need to remember this always. So whenever you see a pair of linear equation, when you apply this, you will be able to say whether it has a unique solution, it has no solution, or it has infinitely many solutions. Infinitely many, I'll get back to that. So next one is 9x plus 3y plus 12 is equal to 0. Okay, what does this mean? And the other is 18x plus 6y plus 24 is equal to 0. I think you can just say the answer just by looking at it, right? 9 into 2, 18, 3 into 2, 6, 12 into 2, 24. a1 by a2 equal to b1 by b2 equal to c1 by c2. Therefore, it has many solutions and it is a dependent pair of linear equations. In this case, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. That's it. Understood? Now let's go to the third one. Third subdivision says 6x minus 3y plus 10 is equal to 0 and 2x minus 3y 2x minus y plus 9 is equal to 0. Here a1 by a2 is equal to b1 by b2 but not equal to c1 by c2 because 6 by 2 is 3, minus 3 by minus 1 is 3. C1 by C2, 10 minus not 3, right? So A1 by A2 equal to B1 by B2 but not equal to C1 by C2. Therefore, these are inconsistent and they have infinitely many solutions. I am really sorry for this handwriting mistake that I can't move to this particular side. It might cover the red thing which I am writing. Okay, cool. So these concepts are very easy, very simple but very integral in solving these kind of problems. Or rather, if you want to get an idea about a pair of linear equations, if you just want to know if it has one solution, if it has many solutions, or if it has no solution. So these three things are very integral in finding that, right? After finding this particular thing, you can apply the methods which we studied to find the solution for those particular equations. That's it. So that's it. We have solved the two problems in our second exercise in the NCERT textbook exercise 3.2. In our next video, we'll go to the third problem. Bye bye.